Hi everybody, today we're going to be doing lesson 83, comparative graphs. Now we've been talking a lot about graphs recently, but today we're going to talk about a graph that will represent two different sets of data in the same graph. So this graph is average daily high temperatures for January and July in Rome, Caracas, Sydney, Paris, and Tokyo. So on this graph over here on our y-axis we have our temperature in degrees Fahrenheit, and then for each city we have two different pieces of data. We have the light blue, which is our average temperature in January, and the dark blue, which is our average temperature in July. So for some of the next few questions we'll be looking at just the January temperatures, just the July temperatures, or comparing them. So let's go ahead and start. Part A, in which city was the average high temperature, the average July high temperature, the highest? So if we look up here at our July temperatures, the dark blue, I want to know which of these is the highest. And looking at the graph, I see that Rome is the highest. So the answer to part A then is Rome. Okay, let's look at question B. You need to refer back to your book for the graph. I will try and toggle back and forth, but you might just need to look at your book. Oh, where did it go? Okay, question B. In which city was the average January high temperature the lowest? So if we go back to the graph, we are looking for the January temperature. Oh, sorry. The average January temperature that was the lowest. And here we see that Paris has the lowest January temperature. Okay, I'm going to leave this up here and just answer or read question C to you. C says, which city had the smallest range or distance between January and July? So my smallest range, I'm looking for my city that has the smallest distance between my two. So Rome has a very large distance. Caracas, pretty small. Rome, bigger. Paris, quite large. And Tokyo, quite large. So without doing any math, just by looking at my graph, I can see that Caracas has the smallest distance. Then the question asks, because we always read the entire question, do you know why it is the smallest? Well, Caracas is in Venezuela, and Venezuela is near the equator. Okay, so if you know about your geography and science and what we learned second quarter, because it's near the equator, their winter and their summer are very similar. All right, question D. For which city is the average January high temperature greater than the average July temperature? So if we look at all of our cities, oh, there's my cursor. Okay. In Rome, July is higher. Caracas, July is higher. Sydney, January is higher. So for question D, Sydney has a higher temperature in January than in July. Why? Because it is in the southern hemisphere. So in Sydney, its winter and its summer are opposite hemisphere. Its winter and its summer are opposite from ours. Okay, so this is a double bar graph. You'll be asked to make one in your lesson practice. Okay, let's go on to example 2. Okay, we can also use a double line graph. This is an example. It shows how things change in relationship to one another. So this line graph shows the change in population in Austin, Texas and Pittsburgh, Pennsylvania from 1950 to 2000. So here are my years on my x-axis and my population, 100,000 people, 200,000, 300,000, and so on my y-axis. So the legend over here at the right, whenever you have a double bar graph or double line graph, you always need to have a legend. Okay? When you make your own, you must have a legend. So the solid blue line with the solid dots is Austin, and the blue line with the hollow dots is Pittsburgh. So, question A, what was Austin's approximate population in 1970? So I know that I'm looking for the solid blue dot line in 1970. I find my year, I scroll up till I find the dot on that line, and I see that it is approximately halfway between 2 and 300,000. So the answer for A then is about 250,000 people. All right, question B. Approximately how much did Pittsburgh's population decrease from 1950 to 2000? So we see here in 1950 that they had a population of 700,000 people, but in 2000 their population decreased to approximately halfway between the 3 and the 400,000, so 350. So 700,000 minus 350,000 equals 10 minus 5 is 5, 6 minus 3, 350,000 people. Okay? So this is a double line graph. Make sure when you make your own that you have your key, your legend, and that your lines are different. If you want, you can use 2 different colors, green and blue, or orange and purple, instead of solid dots or hollow dots. That's fine. All right, example 3. Okay, this one is a little trickier, so I'm going to go through it once, and then we'll talk about it more closely on Monday. So this question asks us to compare line M, this one here on the left, and line K, the one on the right. Which line represents the perimeter of a square, and which line represents the perimeter of an equilateral triangle? So you're going, I don't know. So the first thing we're going to do is we're going to make a function table showing our ordered pairs. So I'm going to start with line M. And my first ordered pair is on the x-axis between 0 and 2, so it's at 1, and right on the line for 4. So my first pair is 1, 4. My next line is, if I follow it up, it's on the 2 and the 8. So my next ordered pair is 2, 8. Go back to my graph, up to my third dot, Follow it down. It's between the 2 and the 4, so it's at the 3 on the x-axis and the 12 on the y-axis. 3, 12. Okay, so let's look at our k. So if I go over here to my graph, if I look at my very first dot right here, again, it's between the 0 and the 2 on the x-axis. It's on the 1. And then between the 2 and the 4 on the y-axis. So it's at 3. So my first one is 1, 3. That's my first point on my K line. My second point, if I follow it up, is on the 2 on the x-axis and 6 on the y-axis. So 2, 6. My third point, if I keep on going, is right here. If I go straight down, it's between the 2 and the 4 on the x-axis, so that will be 3, and between the 8 and the 10 on the y-axis, so it will be at 9. So 3, 9. Okay, so now that I have my coordinate points, what does this mean? We talked a couple of days ago about making an equation. X equals y, something like this, yes? Oh, that's not what I wanted to do. Okay, never mind. We're just going to cross this out. So if I look at this, if I want to know the relationship between x and y, 1x, or 1y actually, if I want to get 4, I have to multiply x times 4. So if I was to plug this in, 8y equals 2 times 4, which would be the x. So this is my equation for m. Over here, my k equation, in order to get 3, I have to multiply 1x times 3. So y equals 3 times x. Now, we know that in a square, there are 4 sides. And we know that in a triangle, there are 3 sides. So if I go back over here, because I have to multiply by 4 sides in order to get y, m is my square. Because I multiply k by 3, k is my triangle. So on your lesson practice, you are going to be asked to write a set of ordered pairs, just like this, and then write an equation like this. You only have to do one, there's only one line, but your answer will look like this for your lesson practice. Do the best you can, and we'll talk about it more on Monday. All right? Good luck.